All right, so check it out. I'm building a device for this man who needs some automation for his incubator. He's got like a 1940s Montgomery Ward incubator that has this kind of device in it that rotates up and down with wire rod trays. So it rotates like this. The problem is it used to have automation on the side, but that's long since burned out. It's gone. And now all he has is this and a hand crank. The hand crank's built very well, but you still have to crank it at least 3 to 5 times a day, and that sucks, especially when you're busy. So what I'm doing for him is building this. Now this may look like a whole bunch of shit, and you're right, it is. There is a whole bunch of shit here, but it all makes sense. This is all just kind of prototyping. This is what it looks like when you prototype. You just have a whole bunch of crap hooked together and you make sure it works. So let's start with this. So this guy here is actually a motor off some RV steps. And when I say off of RV steps, what I mean is I bought this. It's brand new. I didn't pull it off anything. I'm not going to reuse hardware to build something that is critical when like incubating eggs. You need it to be performant, right? It needs to not fail. So that's what this is, brand new. It's actually the motor that causes the steps when you push the button on your RV, the steps to come out or go back in. It's reversible, it can go forward or backward. It's got like, I think it says 18 Newton meters of torque. You're supposed to attach another gearbox to this. And it has like a little finger that moves. Yeah, anyway. So we have this motor here, and this motor has this little keyed shaft in it here. So what we're going to do, you'll see it's keyed on both sides. I'm going to grab the old angle grinder, and I'm going to thin this main shaft here to fit in that. And it has 3 holes here. So what we'll do is we'll thin this, cram it into that, and then screw it to the side of the cabinet, because you can see the side of it is pretty well flat. There's no so this will lay right up against the cabinet. There's nothing fantastic going on the other side. It just, so I think they also use these in window regulators, in car doors and stuff like that, this kind of motor. Anyway, so this is what we're using. So this will work good for sticking into that hole. This guy here is a timer relay, and what that means is, so how do I describe this? So we have a common here, common on the relay, then we have one leg and another leg, and it switches at a given time between this leg and this leg. Now you'll see it's labeled T1 and T2, and that means time 1 and time 2. So on time, off time. So how long it stays on, how long it stays off. You can set these independently of each other, and it'll stay on for, up to, the documentation says 1,000 seconds or 1,000 minutes. Yeah, 1,000 minutes. So it'll stay on or off for up to 1,000 minutes. And you adjust with these dip switches, I believe dip switch C and D, which would be this one and this one. I know it's hard to see, the real small number or letters on there. Actually, I can zoom in a little bit. So yeah, C and D, and you adjust those up or down, and you can adjust the time delay that these actually have effect. So this is 12 volts. Well, it's actually 12 volts to 150 volts, I believe, DC, and 24 volt AC to 240 volt AC. Yeah, words. So yeah, this is workable on both AC and DC, and Down here you have 2 pins. That's your voltage in to control the relay. And then this guy here is a Chinese garbage, what they call reversing relay. So these 3 wires here, you have a common, which would be the black, you have a reverse, which would be the green, and you have a forward, which would be blue. So when you short the black to one of these, it goes forward or reverse. So we just put them on the pin legs here, and when it switches between common, positive or negative or whatever this is here, it shorts these out. You can see this little light works in accordance with whatever it's switching to. So it keeps stopping because because either I'm losing power here or my connections are coming loose. I think it's my connections coming loose. Yeah, it's this green one here. So yeah, when these short, it changes between forward and reverse. This is just a 12-volt power supply I'm using. This is the power supply I ordered, but it came and it was 3 volts, so not the one I needed. But you know, let's hook up the power to this this motor here, and you'll see. So you can adjust this on the fly here by adjusting these. You can adjust it while it's powered. So if we adjust to the left, you can see that when we adjust down counterclockwise, it gets much faster, and if we turn it up, it rotates one direction for much longer. So you can go all the way up, but I'm not going to do that because it'll take much longer to count down again. So yeah, these are pretty cool. Now, what does something like all this cost, right? So this guy here was 80 bucks. You can see there, you can get it on Amazon, $81.42. This guy here, straight from Automation Direct, that $39. You know, you may think that's a lot, but what you can do with it, and you don't have to have anything digital or any sort of configuration or computer or any of that shit, for $39, that's not bad. And they're industrial rated, so they're rated at like 10,000 or 10 million cycles or something. It's in the documentation. It does actually have a cycle count, and it's not on the main page here. But so let's I haven't actually counted how much this is gonna cost. So 81 for the motor, 39 for the relay. That thing, that blinking thing there, is a forward and reverse relay. So that's $17. So we're up to 130. Then we have a power supply we're going to need. So 150. Then we're going to put it all in a box. So plus 33, 186. Then we got some gland ends to protect it all, and we're gonna add 15 bucks for that. I won't count all of what that costs, strictly because we're only going to use a few of these. And then we have also limit switches. So these guys here, and I'm gonna mount those in the top. So up top here. And they'll have little rods that when this comes up, it pushes the rod, and that'll be the limit. So we'll put those probably in the back. And like I said, these are coated and zinc coated and stainless steel for the little rod here and all that stuff, so they're good. There's a 30 bucks a piece. We need 2. So this entire setup, 260 bucks. Now, like I said, that might seem like a lot, but remember, we're using industrial rated stuff. You need to be able to wash down your incubator and clean it out. So that's what this stuff is for. Some of the stuff, you know, like this guy here, is cheap, but it's cheap on purpose because this thing cycles a lot. We want to make sure that this can be replaced for a relatively small cost, and $17 is that relatively small cost. So if this burns out, we don't want to spend 60 bucks on a reversing relay. We want to do cheap, right? This guy here is what matters. This is the brains of the entire operation. And then we need this guy here too, which is going to be sealed and rated for water because this is going to be outside in a damp room. This, I believe, can get damp, but we want it to be inside of that sealed box so that it doesn't cause malfunction. And same as these, you know, these have a bunch of ventilation holes in them. These are not water rated. We don't want these to burn out. Now, the company Meanwell, this MW, might sound stupid. Say Meanwell. These are actually really highly rated power supplies. This one here in particular that I have is actually what's called a DIN mountable power supply. See that little hook on the back there? You mount it on a rail, and you can mount individual devices like this on a rail. But we're not going to use this. We'll use this guy and screw it into the case. So you're looking at 260 bucks in parts. It is what it is. We could have went cheaper, but it wouldn't be as reliable. So, you know, but yeah. The other thing you might be thinking is, you know, how do you get this motor to stop? Once it hits the end of the linkage or the, you know, the Acme thread on the end of that crank, how do you get this to stop? And that's those limit switches right there. So you hook those up. You can hook them up in series or whatever on each leg of these. It doesn't matter. But you hook them up on this motor here, and when that guy hits the limit switch, it breaks the connection to the motor. So it doesn't, we can set it so it doesn't damage, it doesn't like run out the Acme thread here, and it doesn't crash into it, and then on the next cycle it just goes backwards. So it doesn't actually contact the end of the thread. So you won't ever wear that out by impact. You may wear it out through cycling, but never by impact. So you can just, you know, keep that greased or lubricated or whatever. You should be good to go. So I hope this is a good update, and you know, I hope the price isn't too much, but like I said, you want quality, not garbage. So see ya.